Good morning, my lovelies. Right, buddies. Unfortunately, as you can tell, I'm not with you again today. I've got caught by the COVID tracing app, it seems like, that I was in close contact with somebody, apparently. So yeah, unfortunately, I won't be at school again until next Friday. But I suppose, fortunately, I can get back onto these online lessons, which I hope that you guys enjoy. And yeah, I mean, you have the benefit that you can pause and re-listen to them and all of that. I'm gonna, as you've already guessed as well, I put it on the online YouTube channel. So if you check kind of the general channel, like under my name or whatever, you'll be able to find other videos there too, videos that are linked to what we're doing. So I'll always upload them in the same spot. Yeah, so I know it's rubbish that I can't be there with you. I'm actually a bit gutted with it, to be honest, but oh well, I guess that's what you've got to do what you've got to do when the app gets you. So sorry about that, but let's carry on. Here we go. So our topic today is hypothesis testing. Now this is one of my very favorites. This one. It's one of the most challenging things, certainly, though, in the whole of the year 12 stats. So, before we even start, I'm going to do my best to go slow, and again, you can pause the stuff if you need to. But before we kind of move on to it, I just want to say a great big tip to you guys. Please chat to me over the show my homework if you're stuck, okay? Because here's what I'll do. I'll do my best to answer it just by typing to you back, by like texting you on show my homework back. But say a whole bunch of you ask the same question, well, that way I can get that in the next video, because I know it doesn't feel like real teaching, but it is still real teaching. So if you tell me there's something you're not clear on, I can adjust for that in the next one. So please communicate with me is all I would say, because this is a tricky topic. So yeah, hypothesis testing is your title for today, and I like it. So let's get started. Here we go. You need to know a few definitions, unfortunately, buddies, but at the same time, though, it's not like that. What is a sampling frame? What is like an opportunity sample? It's not all like all that rubbish. You just need to be familiar with these words, if that makes sense. You don't have to actually memorize them. Cool. So for us to do this, you gotta know what a few things are. The first one is a test statistic. Now, you actually already know what a test statistic is. It's big X, buddies. So when you're talking about like a probability distribution, remember how there's big X, which is kind of like the sentence. It's how many heads or tails may be coming up or something like that. Well, that's kind of it's kind of the sentence. It is the thing that you're testing against. It is the thing, oh god, it's a terrible definition, that you're testing. That you're testing. Cool. It's the thing that you're going to count. It's big X, and it's the one that you can count it, okay? Now, that's what a test statistic is. Oh, and I should actually tell you, before I get too carried away on this, let me actually tell you what a hypothesis test is. Oh god, I'm coming right into how to do it, and I've not told you what a hypothesis test is. Okay, here's the deal. Here's what a hypothesis test is, buddies. Essentially, say that you had a coin, okay, and you're going to flip the coin, and you're going to count how many heads or tails it comes up. Now, we're going to be dealing with a binomial distribution, so we'd have to have a fixed number of trials. So say we were going to flip the coin 100 times. Now, if you flip the coin 100 times, how many times did you expect heads to come up? Well, if you said 50, you're right, because the chances are 50-50, or a probability of 0.5, right? So if you flip the coin and 50 of them came up heads, you'd be like, oh, it's no problem then. So yeah, there's nothing wrong with my coin. The coin is behaving as normal. Now, what if 55 heads came up? You'd probably be like, oh, I got a bit lucky, 5 extra heads, but still nothing wrong with the coin. That's totally possible that 55 heads may come up. Say you flip the coin again, and now this time 65 heads came up. What would you think? Would you be thinking that, oh wow, I've been very, very lucky, or would you start at this stage to think there might be something wrong with my coin? Maybe there's like a weight, maybe, I don't know, maybe one side is weighted or something. Maybe it's coming down on heads more than it should. That might be what you think, right? See what I mean? Now, take it further. What if you start flipping this coin 100 times, and then this time 80 times it comes up heads? Now, in your head, you'd be like, that is incredibly unlikely, that if I was to flip a coin and to see heads or tails, to get 80 heads, like you're only supposed to get 50, to get 80 is pretty extreme. And then what if it was 85? Well, you get to a certain point, buddy, say you flip the coin, and then 85 times, or even 90 times out of those 100 times, it came up heads. Well, if that was the case, you would stop thinking you were lucky at a certain point, because you got 90 heads. That's insane. You wouldn't be like, I'm lucky. You'd be like, there's something up with the coin. You'd be like, there's something wrong with my coin. And that, my lovelies, is the basis of a hypothesis test. You're going to say to yourself, I don't think I'm lucky anymore. I think there's something wrong with the coin. I think there's something wrong with my initial assumption. So, I don't know, say that you worked at Apple or something like that, and you were making iPhones, and someone says, "Oh yeah, only 1 in a million iPhones come out broken that need to be returned to the shop." Maybe it's a 1 in a million chance that that happens, but then all of a sudden you start seeing that, like, oh my gosh, it's like 75 out of every million of them are coming out wrong. At that stage, you'd be like, I'll bet you there's something wrong with the manufacturing process, and you'd have to say, you know what, I don't think we have this right here. We need to perform a test to see if our machine is broken and we need to change. Cool beans, buddies? That's the basis of a null hypothesis. Or, no, not a null hypothesis, of a hypothesis test, sorry. So it's just kind of saying, I'm not sure if my presumption's right, and I think something's up. That's what a hypothesis test is. Okay, so sorry, now going back to this, the definitions. The test statistic is the thing like how many heads or tails came up. It's big X. See what I mean? It's how many heads or tails came up. It's counting something. It's how many heads. Cool? Now here you go. Knowing that, then, this is going to seem strange, but it'll make sense in a minute. You've got to always have, when you do these tests, what's called a null hypothesis. This is kind of like the default hypothesis. This is how it's always been. Default hypothesis. Hypothesis. And it's as though nothing is up. Nothing has changed. Nothing is wrong. Nothing has changed. Has changed. So, in other words, if it was the flipping of the coin, the null hypothesis here would be, for instance, P, the probability of getting a heads, is 0.5. Because that's what you'd expect, right? Before we know our coin is broken, we would expect that, okay? Now, that's what a null hypothesis is. The alternative hypothesis, this is what we actually feel is going to be happening. What we think is actually happening. Actually happening. Okay, now a coin, back to our coin. We started flipping the coins, right? The null hypothesis has to be the chance of a head is 0.5. That's the null one because we are assuming it's a normal coin, so the chance of getting heads is 0.5. But if you get 90 heads, our alternative hypothesis, well, our alternative hypothesis is simply this. It's that it's greater than 0.5. Okay, the probability is greater than 0.5. We'd think that because you got way more heads than you thought. Now there's special notation here. Null hypothesis is H0, and alternate hypothesis is H1. Boom. Significance level. This is how sure you want to be. How sure do we need to be? Do we need to be? And I know I'm giving you really non-technical definitions here, but you will get it shortly. So for instance, if I had, maybe let's do a 5% level of significance, that means I'm not willing to say that my coin is actually weighted towards heads unless I can be 95% sure of that. So I don't want to go to whoever gave me the coin and say, you've given me a dodgy coin. I don't want to put myself on the line like that unless I'm 95% sure, and that's the significance level. Whew! Good, my lovelies. Hooray! I can't believe I'm teaching the hardest lesson through online, but cool. I hope that that's okay to begin with, and I hope it makes more sense right now. Cool. Now, here we go, buddies. Let's just see if you got your head around it. So let's read it together. It says, John wants to see whether a coin is unbiased. Oh, good, it's about the coin, just like what we did. Good. To see whether a coin is unbiased or whether it is biased towards coming down heads. It's our exact example. He tosses the coin 8 times, and he counts the number of times, X, that it lands on the that lands heads uppermost. Okay, it says describe the test statistic. Okay, what's the test statistic again? That's right, it's big X, buddies. It's exactly right. The test statistic is big X. So what is big X? Well, actually, it kind of gives it away in the question this time, but you guys will sometimes have to make it up on your own. But the only thing to remember, really, buddies, is that big X is a counting variable, okay? It's how many times does the thing happen that you want. It's from the binomial distribution. So here we go. What's the test statistic? Well, it's this. The test statistic is X, and that's just going to be the number of times it lands on heads. It lands on heads. Cool? Good. Now, here's where it gets good. This is where we actually have to think a bit about it. So, quick peek at B. Now, here's where we get good. Okay, B, and I'll write down C as well. Okay. Now, this thing here, a suitable null hypothesis. So remember, null hypothesis is H naught, and you generally put a little colon next to it, H naught. And here's what you got to think. The null hypothesis is as though nothing was wrong. It's kind of our base assumption. So here we go. H naught, what's it going to be? Well, it's going to be P equals 0.5. The chance of getting ahead is 0.5, right? Because it's 50-50, and that's as though there's nothing wrong with our coin. Write down a suitable alternative hypothesis. I sometimes call it an alternate hypothesis, but alternative hypothesis. Well, that's H1. What do we think is happening? So in our hearts, what do we think is happening? He wants to see whether the coin is unbiased or whether it is biased toward coming down heads. So what is it that we think? We think it's coming down heads more, don't we? Which means for it to come down heads more, we would think the probability then of it coming down heads is more than 0.5. And that's all there is to it, buddies. Does that make sense? Good. Right. So here we go. Example 2. Now, example 2 is kind of similar. So what I would suggest is you should try A and B. You should push pause in a sec and try A and B and see if you can do it without me helping you, and then I'll quickly do it after. So you ready? Pause. Okay, and now that you've unpaused, let's have a look. It says an election candidate, oh, it's so timely this. An election candidate believes that she has the support of 40% of the residents in her particular town. A researcher wants to test at the 5% significance level, so there's a new term, whether the candidate is overestimating her support. The researcher asked 20 people whether they support the candidate or not, and 3 people say that they do. Write down a suitable test statistic. Okay, so here we go, buddies. Write down the suitable test statistic. Let's do it. Oh, came up. Oh, there we are. A. Write down a suitable test statistic. So what are we going to try to write down as our test statistic? What's that counting thing that we're on about? Well, here we go. We think that they're overestimating the vote. The researcher asked 20 people whether they support the candidate or not. 3 people say that they do. So what are we going to use as our test statistic? What's big X going to equal? What are we counting? That's right. It's the number of people, because it has to be something you can count. It's the number of people who support the candidate, when they're asked. Cool, does that make sense? Perfect. Now here we go. For B then, buddies, for B, we can go for this now. Write down 2 suitable hypotheses. Now you guys are already pro, so you know the 2 hypotheses are H0, the null hypotheses, and H1, the alternate hypotheses. Now here we go. This is the thing. The null hypothesis, one more time, is the default position, okay? It's what you think could actually, is what you think the actual base position is. So an election candidate believes she has the support of 40%. So what's the chance of somebody supporting her before we think that something is up? Well, that's right, 40%. P equals 0.4. Exactly that. Beautiful. Now, the alternate hypothesis is what we actually believe to be true in our hearts. So a researcher wants to test at the 5% significance level whether the candidate is overestimating her support. So we are like the reporter, and we are the researcher, and we think that it's not. We don't think that her support is at 0.4. What do we think? We think we think she's not as good as she thinks she is. So here's what we think. We think that it's less than 0.4. The reason being is we think she's overestimating. So we think she hasn't got a 40% chance of success, but rather she has got less than a 40% chance of success. And boom, there's your two null and alternate hypotheses. Now, part C is not super important, and it will make a great deal. It'll make a great deal more sense when we actually get to use numbers in a sec. But here we go. Explain the condition under which the null hypothesis would be rejected. I'm not even going to write it down because it makes more sense with numbers, but I'll say it for you in case you've had a chance to read it. Okay. Here's what you do, my lovely. See, we're at the 5% level of significance. Essentially, we actually do the experiment now. 3 people say they support her out of 20. So 3 people out of 20 support her. 3 divided by 20. So that's only a 15% chance of people supporting her, right? Now, this is it. With only 15% of people supporting her based on this little survey thing that we did, what we'd have to be sure of is we'd have to be 95% sure that that's not just down to luck, okay? That's essentially what that is. We'd have to prove to ourselves with the hypothesis test, which we'll do in a sec, we'd have to prove to ourselves that there is less than a 5% chance that it is going to happen naturally. In other words, we're 95% sure that that she's got less than 40% support. Now that's hard to explain, so here's what we're going to do. A one-tailed test. This is going to be the last thing I think I do with you today, because I'm conscious of how long this video is. So here we go. The subtitle here, this is actually testing now. So put down the title, one-tailed tests, okay? One-tailed tests. So jot that down. And we're going to do this one together. Your first ever hypothesis test, you lucky ducks. So please put the title, one-tailed tests. Okay. Now here we go. If you can do this, you're flying. This is the hardest thing in the whole course. How exciting. Okay. Here's what it says. It says the standard treatment for a particular disease has 2/5 probability of success. Cool. I'm just going to highlight as we go along so we can read faster. 2/5 probability of success. A certain doctor has undertaken research in this area and produced a new drug, which he believes has been successful. Which has been successful with 11 out of 20 patients. So in other words, he's got a 55% chance of success there, whereas 2/5 is only 40%. Therefore, the doctor claims that the new drug represents an improvement over the standard treatment. Test at the 5% significance level the claim that is made by the doctor. Okay, here we go. This is going to be quite kind of systematic, and you can get so many marks. Like these tests, these questions are worth like 4 or 5 or 6 marks. Oh my gosh, if you just follow the pattern, buddies, you will always crush this, okay? So you're going to memorize the method, and you're just going to carry out these tests in the same manner that I do here. So here we go. Let's try it. Hey, to start with, step 1 every single time is you need to lay out what we're actually doing. We need to know what big X is equal to. So step 1 is this, buddies. Write down big X equals. Now, we have to know what big X equals. We're on about a doctor testing drugs, okay? What's he counting? Like, look at this, the 11 and the 20. What is he counting? That's right, he's counting the number of patients who are helped by the drug. Cool. Does that make sense? I'm going to call it the treatment, because they call it the treatment. Yeah. So, it's the number of patients who are helped by the drug. That's what the counting thing is, right? It's the number of patients who are helped by the treatment. Cool beans. Now, the next step after that, then, my buddies, is you're going to have to come up with your hypotheses. We're going to have to actually do the test. So, step 1, write down what the variable is. Step 2, though, buddies, is to do the hypotheses. So, what we're going to have here is we are going to have H0 and H1. Now, here's what they are, buddies. H0, the null hypotheses. This is as though nothing has happened. It's the default position. So my lovelies, what was the chance of success of the drug before we had our new drug? What about the old drug? What was its chance of success? Well, if you said P equals 2/5, you would be absolutely right, because the 2/5 is from here. Cool? Because that was the old drug. Now the other thing that we're going to do, buddies, is this. We now need to come up with the chance of success for the new drug. Now we have to now think about what's our alternate. What do we think is actually going to happen? Well, we're the doctor. What do we think? We think the new drug is an improvement, which means our chance of successfully treating the person is not going to be 2/5, but greater than 2/5. And that's it. Cool, cool, cool. Now, next step, buddies. Next step is this. We're going to write this sentence every time. You're going to write this. Assume H naught is true. Because that means that we're going to go from the position that the old drug is fine still. And here's what we're going to do. Then, if H naught is true, it's this. X is going to be a binomial distribution, because of all the four things that make a binomial distribution. It's got a set number of trials, success or failure, fixed chance of success, and independence. So X is going to be a binomial distribution with how many patients did we test? That's right, 20. What was our chance of success if H naught was true? That's right, 2/5. Like a boss. Cool? And now, and then that's it. We're testing at the 5% significance level as well. Now here we go, buddies. Final thing I'm going to get you guys to do, or the final thing now, is to actually conduct the test. So I hope that this is okay, and now we're going to conduct the test, which is the fun part. Actual hypothesis test. Draw yourself a little sticky line like this, kind of a little bit like linear interpolation. Make yourself a little sticky line like that. What's going on our line then is this. We are going to have to, I'm going to make my line longer because I'm going to draw on it more. Okay, we'll make a big, long, sticky line like this. And what we're going to be measuring on it is how many people were helped by the drug. So the minimum number of people that were helped by the drug is 0, because maybe it didn't help anybody. The maximum number is 20. Cool? In the old drug's case, so in the old drug, which had 25% chance of success, I'll pop my calculator open here. Both calculators open here. In the old drug, you had a 25% chance of success. Well, here's what you're going to do. Well, how many people would you expect to be cured? Like, what's the mean? If you have 2/5 of 20. That's right, my lovelies, it's 8. So here you go. Mark on there also 8. The reason why we did 8 is because that is what 20 times 2/5 is, right? And that's just on there just to give us an idea. Now the next step, buddies, is we have to actually consider what's called the significance level. So the significance level, my buddies, is 5%, right? It wants to be tested at 5% significance level, and we're testing that the probability is greater than 2/5, okay? So we think that it's more than 8 is what's going to be coming up, and here we go. What you do is you draw this little section, like a little green line or a little different colored line if you can, and kind of gently just hash it in like that. Don't be coloring it because we're going to be drawing underneath it, but a bit like that, okay? So just a little green line. That 5% is going to go here. You're going to write 0.05 because that's 5% as a decimal. And here's what you're going to do. We're going to find what's called the critical region. What you do to do that is you put a little stick just to the outside of the boxed off area and just to the inside. We're going to try to figure out what these two numbers would be that match up with each of those red sticks, and that'll tell us if we're 95% sure that his new drug isn't better down to chance. So here's what you've got to do. You know we're after 5% significance, right? From here to the green, that means, is 95% significance. So here's, and this is going to be hard to do without showing you, but here's what you're going to do. I'm just going to talk it out. Get the big calculator out, your big one, okay? Now, what we're going to have to do is we're going to have to get into the binomial BCD, binomial cumulative. So push menu, so push pause if you don't have the calculator, go get the calculator, and here you go. Push menu, choose 2 for stat, choose distribution, which is the second to final one, F5, choose binomial, which is F5 again, and choose BCD, which is F2. Cool? Data is variable, and here's what we're going to do. X we don't know, okay? That we're going to have to guess at X, okay? X we don't know. Number of trials, though, is 20, because that's the number of people, and the chance of success we're using the H naught is 2/5. So just write down 2 divided by 5 in the calculator, which magics itself to 0.4. So now that's in the calculator. Now we're going to guess a number bigger than 4, okay? Or sorry, we're going to guess a number bigger than 8, I should say, because we think that we have a higher chance of success. And we're going to be trying to aim for a probability that is above 0.95. So you ready? Pick any old number for X. I'm going to go with 10. If I put in x for 10, I got 0.87 as my answer. That's not high enough. See what I mean? It has to be above 0.95. So it wasn't 10, so go for a bigger one. 11. Oops, I changed the wrong one. 20, and then back up to here. Let's go to 11. Right, 11's not 0.94. That's really close. So it's not 11 either. But how about 12? Okay, 12 gave me 0.97 in the calculator. So 12's our magic number. Here's what you're going to do with your magic number of 12. We're going to have to be doing a bit of a calculation here. But since we're calculating to the right, because the calculator can only calculate to the left, it does less than or equal to. We're going to have to do a bit of funny work here. So let's try it. We're going to do this. We're going to be probability of x being greater than or equal to something, and it's going to be 1 take away the probability of x being less than or equal to something. Okay? We want to get an answer that is less than 0.05, which means the something that we take away has to be bigger than 0.95. Remember how we just tested and trialed and errored and got 12? Put a 12 there, because that's going to give an answer that's bigger than 0.95. Cool? If that's a 12 there, this is a 13 here. Does that make sense, buddies? I hope it does. That's the hardest part. Yeah, because if you had 12 or less, that's going to get you bigger than 0.95. So when you take that away from 1, you're going to be left with a number that's less than 0.05, which is what we want. So here's what you're going to do now, and I'm going to have to talk it through again. With your little calculator, we're gonna be bosses and dual wield our calculators. And here we go. In the little calculator now, you're gonna go 1 take away, and then from the big calculator, the number was 0.979. It is 0.979. Sorry, I typed that wrong again. 0.979, and you should get an answer of 0.021. Okay, so that should be 0.021. Okay, the number that produced that was 13. Okay, 13 therefore is in there. So this 13 is this 13. It's in there because this is 0.05 here. The whole green section is 0.05, but this 0.21, and you don't have to draw this on yours. I'm just going to go over the top and explaining it though. This 0. Ooh, I need that to be a different color though. This 0.21 here, 0.21, actually matches up with that. So it's less than 0.05, you see? So that's why it's inside. Now we just got to do one other thing. It's called bounding it. This number is going to be 12, right? Because if 13 was the first number in, 12 is going to be the next number. So we just need to do the same here. Probability of x being greater than or equal to 12 then is going to be 1. Take away probability of x being less than or equal to 11. Now we got to do that just so we can know what is the number that's less than 95%. So here you go. This 12 is this 12. And now we need to get calculators going. So big calculator, go back in the big calculator, change the 12 to an 11. Gives 0.943. Little calculator now. Little calculator. 1 take away 0.943 equals, and it's 0.057. 0.057. So 0.057. Now to really labor the point, what's happening here? That 0.057 is bigger than 0.05, and it's because it's this entire region here. So it's outside of the green section. It's more than the green section. Cool? Well, guess what? You've essentially just done your hypothesis test, and we only have 1 sentence away from victory. Okay. Here's what it means, buddies. Here's what it means. It means that if the doctor actually started using this new drug on patients in a trial, if there were 12 or fewer successes, then whilst it seems like the new drug is better, we are not 95% sure of that. Do you see? So we'd expect there to be 8, but if there 8 people get better. But if there's all the way up to 12, it could be down to statistics, or maybe people getting the drug being a bit healthier or something like that. If there are 12 or fewer, it means that the new drug isn't actually better. Or it might be better, but we're not 95% sure it's better. However, if there are 13 or more people that are helped by the new drug, that is so unlikely to be down to chance that what it must mean is that the new drug is better. We should put all the old drugs in the bin, and we should be using the new drug because it's curing people at a higher rate than the old drug. Not only that, we're 95% sure that that's the case. Boom, hypothesis test. So that's it. That's a critical region. That's what you've got. Now, I'm just going to finish this off, then I'm going to cut this video short, I think, because I feel like I've talked for ages. So, and you'll get lots of chance to practice, so don't worry. We've timed these lessons really well so that you have lots of chance to practice. So, ready to go in for the kill? Our doctor has found that 11 out of 20 of his patients were cured by the new drug. Okay? We have just done our hypothesis test, and for the new drug to be better, how many patients did we need to see get better? In order to declare that the doctor's new drug is better, how many people had to get better? That's right, 13. And we only had 11 getting better. So here you go. Are you ready? Here's what you write down. Our new drug isn't better, buddies. It probably is, but we're not 95% sure it's better. We need to go back to the drawing board, either test more people out or make an adjustment to our drug. So here's the sentence that you write to get the marks, though. You write down this. You write down, so H naught is accepted. Now, that just means that the default position, the old drug, is still the right one, okay? That's what that means. So H naught is accepted. We are not 95% sure that the new drug is better, that the new drug is better. Drug is better. Now, that's killer because we are certainly 90% sure. We're actually like 94% sure that the new drug is better, but we're just not 95% sure, and that was our criteria. We're not going to throw our machines in the bin that made the old drug. We're not 95% sure that the new drug is better. So yeah, the doctor, while he's made an improvement, hasn't actually shown that the new drug is better to 95% certainty. Bish bash bosh, you've now got your first ever hypothesis test done. So yay, good work. Okay, here's what I'm going to get you guys to do for your practice / homework. I'm just going to have a quick read of this because I was going to do this one with you. A single observation X is taken from a binomial distribution. A value is 5 is obtained. Test this and test that. It's taken from a binomial distribution. The value is 5 is obtained. Okay, what you got to do with these bad boys here, I'm just going to rattle it off as quick as you can. You can't say what the random variable is. You know your H naught is equal to 0. H naught P is equal to 0.25. H1 is going to be P is greater than 0.25. It's not a worded one, so it's a bit funnier, this. And here's what you're going to do. Test at the 5% significance level. Here's how you do it, guys. X is a binomial distribution with 10. And actually, we'll have to do the H naught as accepted. Assume H naught is true. I wasn't going to do this question. Okay, now I am going to do it. Oh, I feel invested in it now. Now I am going to do it. Okay, here we go. I wasn't going to. Now I am. Sorry, on the fly. Changing my mind. Okay, here's what you're going to do. You can't say what big X is. Lay out your two hypotheses. H naught is P equals 0.25, stolen directly from the question. H1 is P is greater than 0.25, stolen directly from the question. Next step, assume H naught true. Assume H naught is true, just like the last question. That means what we've got is X is a binomial distribution with 10, stolen directly from the question, and 0.25, which is the null hypothesis. If H naught is true, all I want you to do is this. Do that line thing that we just did, okay? So in this one, the line thing is this. You could have 0 successes, because that's the smallest. You could have 10 at this end, because the 10 is from there. Cool? We'd expect there to be 10 times 0.25, so we'd expect there to be 2.5, so just put that on there for good measure, and we're testing at the 5% significance level. Cool? 5% significance level. Now, that means this part here is the 0.5. 0.05, I should say. What you're going to do right now for this question, and like maybe two others, is this. Get me what that number is. Get me what that number is. That's that whole big calculator to little calculator thing. So it's going to be probability of X being greater than or equal to something is equal to 1 take away probability of X being less than or something. Then you do the same again. Cool. To get the lower one, take probability of x being less than or equal to something. Cool. And then final step then is you'll say what these two numbers are. Say that it's 6 and 7, for instance. So just making this up. So this is not right. I made this up completely, as you can see. Say that's 6 and 7. Well, if you got 5 then, because they said it was 5, if they got 5, that would mean that H0 is accepted, which means you don't have new evidence to show blah, blah, blah. Okay? That's all you gotta do. Just say H not accepted or not. It's less work than the previous ones, but I felt I had to show it to you, so sorry about that. Yeah, cool. I really look forward to seeing you again in person, and that's cool. All I want you to do is page 106, just question 2, 3, and 4. Okay? See if you can do it. Upload it on Show My Homework like a homework. I won't give you any homework, so so this is your homework in essence. I'll check for completion on these. They're not optional, but I won't be setting an additional homework. Okay? Alright? And that's it from me. Have a lovely day. Goodbye, my lovelies!